Hi guys, welcome back to my channel. Today we'll be treating some topics in algebra, the likes of indices, logarithm, binomial expressions, quadratic equations, simultaneous equation, matrix, and Surd. We'll be solving at least one question from each of these topics I mentioned now. Let's get to the first question. We have simplified the following. We have the question A and question B. Of course, question B is an equation, and question A is a logarithm expression. We have to simplify A and then solve the equation at number B. So we have the log of 24 to base 3 plus the log of 18 to base 3, that's solution A, minus, so all the factors have the same base, so we simply take one of the base. This is a logarithm to base 3, a log to base 3, and log to base 3, so we take just one of the logarithm to base 3, and of course the law says when you pick one of the base, addition means you multiply the first two numbers, that's 24 multiplied by 18. A logarithm minus between two logarithms that has the same base means dividing the numbers involved. So when we multiply 24 by 18, because of the plus we multiply 24 by 18, then because of the minus we're going to divide everything by 48. Okay, so we have to multiply the values. 24 multiplied by 18. 24 multiplied by 18 is, we're going to have there logarithm of 432 divided by 48. Okay, and that's equal to 432 divided by 48 is equal to 9. So we have the logarithm of 9 to base 3. So how do we now simplify this? The index, subject 9 to index, so that we have that's to be equal to the logarithm of 3 raised to the power 2 to base 3. That's 3 raised to the power 2 is equal to 9. Then you perform the law front to the back, the front to back law. So 2 is going to move from the front to the back of the logarithm. So we now have finally 2 log 3 to base 3. And of course, log 3 to base 3 is equal to 1 because the logarithm, the number and the base are the same. So the logarithm is equal to 1. So we're going to have 2 times 1, which is equal to 2. So my answer is equal to 2. Okay, then the B part of the question. Question we have B equal to 2 log x to base 10 plus 3 log x to base 10 equal to 75. Okay, that is a little mistake here. Here is supposed to be x and not 3. Okay, so we have x there. So how are we going to solve this equation? You find out that we have like terms here. 2 log x to base 10 plus 3 log x to base 10. Of course, will give us 5 log x to base 10, then equal to 75. Okay, so the next thing we're going to do now is we are going to let p equal to, or let's say let log x to base 10 equal to p. As far as this condition is concerned, I'm going to have 5, then log x to base 10 is now p. 5p is equal to 75. So that p is equal to 75 divided by 5 which is equal to 15. Then we can now go back to find the value of x. So since p is equal to 15, then we'll substitute here. We now have therefore the log of x to base 10 is equal to 15. Now according to the definition of logarithm, the base raised to the power 15 must be equal to x. That's the relationship between logarithm and indices. So when a logarithm is represented in this form, and you are to change it to initial equation, you must take the base and raise it to 15. That's the number after the equal to sign, and make everything equal to what? X. So what I mean that is from here, x will be equal to 10, which is base raised to the power 15. Answer. Okay, let's get to the next question. Now this is the second question, and of course this under indices. So we have solution. So that we have 3pq raised to the power 7 or q multiplied by 7p the square root of q raised to the power 8. So according to the law of indices, the power outside affects all the terms within the bracket. So the power of 3 is going to affect 3, affect p, and then they affect q raised to the power 7. So when we affect this power to all the terms within the brackets, we have 3 raised to the power 3 multiplied by p raised to the power 3 and q raised to the power 7, then times 3. Then everything multiplied by, coming to this side, we have 7p, of course, q raised to the power 8, all square roots, the square root of q raised to the power 8 means q raised to the power 8 all multiplied by 1/2. So here is 3 raised to the power 3 is 27, p raised to the power 3, q, of course, 7 times 3 is 21, then all multiplied by 7p. 8 multiplied by half is 8 divided by 2, here is 4. So that we're now having q raised to the power 4. And we last say 8 will multiply 1/2, and of course when you multiply it will divide to give you 4. So that we're going to multiply the letter to the number will multiply number, and then each of the alphabets will multiply the other alphabet on the other side. So the first thing to do is we're going to have 27 multiplied by 7 as the first number to number, then p raised to the power 3 multiplied by p, then finally q raised to the power 21 multiplied by q raised to the power 4. So that we have 27 multiplied by 7 will give us 189, and then p raised to the power, this is like the power of 1, so we have 3 plus 1. Of course, you take one of the base and then add the powers together. So we now have q raised to the power 21. Of course, multiplication means addition. You take one of the base, which is q, and then add the powers. That's we have 21 plus 4. So finally, the answer becomes 189 p raised to the power 4 q raised to the power 25, and that eventually becomes the final answer. Then the B part of the question says we should simplify x raised to the power 5/2 multiplied by sub x. Okay, so we have this is x raised to the power 5/2 multiplied by sub x means x raised to the power half. Okay, then since the bases are the same, we're going to take one of the base and we add up the powers, so we have 5/2 plus 1/2. And when that happens, we're going to have x raised to the power, of course, the LCM is 2, so we have 2 here, and then 5 plus 1, so add up the LCM. So the final answer becomes x raised to the power 6/2, and 6 divided by 2 will give us 3. So we have x raised to the power 3 as the final answer. So the next question is question 3, and that is under binomial expression. This is another example, that's the binomial expansion. Then we are asked to find the first 5 terms in the expansion. So we can actually solve this equation, we can actually solve this question in 2 ways. Either we solve it by Pascal triangle or the use of binomial formula. So first, let's try solving this equation using Pascal triangle. Then we have to draft out the Pascal coefficients up to the power of 5. So the Pascal coefficients corresponding to the power of 5. We're going to have a Pascal triangle first. So we introduce the Blaise Pascal triangle. Blaise Pascal triangle. We have 1. Then we shift here, we have 1 here, we shift again, we have 1. And then the next is to shift again from this one. That's how we have the first line, the second line, and the third line we start adding. So 1 plus 1 is 2 written under here. Then we shift away from here and I have 1. We shift away from this one, 1. 1 plus 2 is 3 middle here. 2 plus 1 is 3, write it under here. Then we shift away from here, we have 1. We shift away from this side with 1. 1 plus 3 is 4 under here. 3 plus 3 is 6, you write it between them. So we have 6 here. 3 plus 1 is 4 between, at the middle, we have 4. And we shift away here with 1. The last one, we shift away from this one with 1. 1 plus 4 is 5, and then right in the middle, 5. 4 plus 6 is 10, right in the middle, 10. And 6 plus 4 is another 10 in the middle. And then 4 plus 1 is 5, right in the middle. Then shift away from here and have 1. So actually, this is the Pascal coefficients corresponding to the power of 5. So once you have, I think we have 6 here, then we have to do another one that will have 1, 6, right? So when it is 4, we're going to use the Pascal coefficient that starts from 1, 4. That is if here is 4. So since here is 5, we're going to use this one that starts with 1, 5. Okay? So now, this is the Pascal coefficient we're going to use to expand this up to the 5 times or 6 times. You can even exhaust it. So now, we have the first coefficient. The first coefficient here is 1. Meanwhile, our question says 2 minus 5x all raised to the power 5. Of course, the expansion is going to be, the first coefficient is 1. So we have 1 into, then the number we have here is 2. We have 2 raised to the power 5. Followed by, of course, we start with the first one raised to the power 5. Then the second term there is minus 5x. So we have minus 5x but raised to the power 0. That's how to do it. Then the next coefficient is 5. So we have 5 into, then 2, you remove 1 from the 5, we have 2 raised to the power 4 into, then you add 1 to this 0, minus 5x raised to the power 0. Okay? Plus, the next coefficient is 10. We have 10 into, then the 2 raised to the power 4 will reduce to 2 raised to the power 3. And then, this is 1. We have 0, add 1 to the 0, we have 1. So now, we have minus 5x. We have this 2 raised to the power 4 reduced to 2 raised to the power 3. Then, this 1 will increase to 2. So we have 2 here. Plus, the next coefficient is 10. Then we have 10 into 2 raised to the power. Then the power of 3 will reduce to 2. Then this minus 5x, the power of 2 will increase to 3. We have minus 5x raised to the power 3 plus the next coefficient here is 5. We have 5 into, then 2 raised to the power 2 reduced to 2 raised to the power 1, and then minus 5x will increase to raised to the power 4 plus the final coefficient there is 1, so we have 1 into, then 2 raised to the power 1 will reduce to 2 raised to the power 0, then minus 5x will be minus 5x raised to the power, then you increase this 4 by 1, you have 5. Okay, so we're going to laterate off. This is equal to 2 raised to the power 5 is 32. 32 into, of course, 1 times 32 is still 32. Then 5x minus 5x raised to the power 0 is what? 1. So we have plus 5 into 2 to the power of 4 is 16. Everything multiplied by minus 5x. Because minus 5x raised to the power 1 is still minus 5x plus 10 into 2 raised to the power 3 is 8. Then minus 5x raised to the power 2, of course, the square of negative is positive. Minus 5 raised to the power 2 is plus 25. So we have 25. Then x squared is still x squared plus 10. 2 raised to the power 2 is 4. 10 times 4. Then because this 3 is an odd number, minus 5 raised to the power 3 will give us minus 125. Then x raised to the power 3, because obviously the raised to the power 3 is affecting both minus 5 and x. Okay, so minus 5 raised to the power 3 means minus 5 multiply itself 3 times. Minus 5 times minus 5 times minus 5. Okay, something like this. That's minus 5 multiply itself 3 times, so that minus cancels minus. You find out that 5 times 5 times minus 5 will give us minus 125. Then the x affecting and the 3 affecting x will give us x cubed. So we have plus 5 into 2 raised to the power 1 is 2. Of course, this is an even number, just like saying minus 5 raised to the power 4 is times another minus 5. This minus will now multiply this minus, it will cancel it off to give us plus. Okay, so that we can have we can have 625. We can have 5 raised to the power 4 to give us 625. Then x raised to the power 4 plus 1 times 2 raised to the power 0 is 1. Then minus 5 raised to the power 5, because the 5 as the power is an odd number. And 6 is an odd number. We have minus 3125. That's minus 5 raised to the power 5 is minus 3125. Then x raised to the power 5. So finally, since they say the first 5 times, we can actually stop here. We can actually stop in the 5th one, but let's complete it. So we have this equal to 32 plus. We're going to multiply out our answers now, so that we have 5 times 16 times minus 5 will give us minus 400. So everything here will give us minus 400x. Then plus 10 times 8 is 80, multiplied by 25 is, we have 2000x squared. Minus, that's this plus here, by this plus here multiplied by this minus is going to give us a resultant sign of negative. So we have 10 times 4 is 40, then multiplied by 125 is 5000. 5000x raised to the power 3. Coming here, 2 times 5 is 10. So 10 multiplied by 625 is 6250 x raised to the power 4 plus, that's the last answer, plus times minus is minus. Plus here multiplied by this minus is minus, so it should be minus 3125 x raised to the power 5. and that eventually becomes the expansion. So we have 1, 2, 3, 4, 5. So we can actually stop at this particular one since the question requires only the first 5 times of the expansion. So one can actually stop here if you must do exactly what the question said. Okay, so I decided to complete the total expansion. Alright, we have number 4th question here. Find the roots of the quadratic equation 2x squared minus 3x plus 4 equal to 0. So we are going to use either factorization method, that is if it is factorizable, or we can choose to use the almighty formula, that's the formula method, that's the general formula, or we can use the calculating the square method. So, but what I want us to use now conveniently is the general method, that's the general formula. Of course, we have the question 2x squared minus 3x plus 4 equal to 0. Then comparing this equation with the general expression for quadratic equation plus bx plus c equal to 0, then obviously a corresponds to 2, b corresponds to, that's the coefficient of x is b, the coefficient of x here is minus 3, so b is equal to minus 3, then c corresponds to 4. Then when we state the equation, we say is x equal to minus b plus to minus the square root of b squared minus 4ac all over 2a. We can now solve. X is equal to minus from the formula, then b itself is minus 3. The minus I have written down here, the minus you're seeing here now is from the formula. Then b itself is having minus, so we have minus 3 plus or minus the square root of b squared, that's b is minus 3. We have minus 3 square, then minus 4, then a is 2, 4 times 2 times c is what? 4. All over 2 times a is 2. Okay, so we have x is equal to negative is positive, so we have 3 plus or minus the square root of minus 3 all square will give us plus 9, so we have 9, then minus 4 times 2 is 8, and 8 times 4 is 32, all over 2 times 2 is 4. So we're now having x equal to 3 plus or minus, of course, we are going to subtract 9 minus 32 will give us minus 23. We have minus 23 all over 4. Okay? So and that's equal to x equal to 3 plus or minus the square root of course, that's a complex number here. This is the same thing as saying the square root of minus 1 multiplied by 23. Minus 1 times 23 is the same thing as minus 23. Okay? This is x equal to 3 plus or minus this the square root of minus 1 multiplied by 23 according to Surd. According to Surd, we can break up this square root so that we have minus 1 separately. Minus 1 in the separate square root multiplied by Surd 23. That's a 23 and another square root all over 4. Then according to complex numbers, the square root of minus 1 will be equal to I. That's a complex number I. The square root of minus 1 will give us I. Okay? All you just need to do, if you have this calculator, is pretty much simple to do. Then watching this calculator now, you see that we can actually get the square root of minus 1. You can put your calculator in complex mode. You can say, of course, when you click on complex, you hit on number 2, that's mode. We go for mode option. Then number 2 there is complex. And once you're in complex, you can now punch square root of minus 1 equal to, you see, it gives you I, right? Okay, so we have I surd 23, that's I multiplied by surd 23, all over 4. Okay, so finally the answer becomes x is equal to 3 plus or minus surd 23 I all over 4. Okay, so if you want to split it now, you can now use plus first to get the first value of x and then minus to get the second value of x. That is, we can say x is equal to 3 plus surd 23 over 2 I, or 3 minus surd 23I all over 4, and that's 4, not 2, all over 4. So that eventually becomes the final answer. So the next is question number 5. This question says solve the simultaneous equation. Of course, we have A and what? B. So we have solution. The first, A says x plus 2y is equal to 5 and 3x minus y is equal to minus 6 is equation 1 and that's equation 2. Okay, so we can use the elimination method. So elimination method, we're going to multiply equation 1 by the coefficient of x here, which is 3. We have 3 times equation, this 3 here will multiply the whole of equation 1, we have x plus 2y equal to 5. Then the coefficient of x here is 1. We use it to multiply equation 2. So 1 will multiply equation 2, which is 3x minus y equal to minus 6. Okay, 3 times x is 3x. 3 times minus plus 2y is 6y. And 3 times 5 is equal to 15. 1 multiplied by this will give you exactly the same thing without any change, minus 6. So we've succeeded in making the coefficients of x to be the same. So you watch now, you find out that we have 3x here and we also have 3x here. So we can eliminate x to be able to find y using negative equation 1, the equation at the top minus the equation below. So we use minus 3x minus 3x is 0. Then we have 6y minus, that's we have double minus here, minus here and minus here. That's we have the minus bracket minus y equal to 15. Minus and also another minus. So we have minus into minus 6. Right? So negative to negative here is positive. We have 6y plus y is equal to 15 plus 6. 6y plus y is equal to 7y. 7y is equal to 15 plus 6 is 21, and y is equal to 21 divided by 7, which is equal to 3. So to find the value of x, we're going to substitute. So we're going to put y equal to 3 in equation 1. Of course, equation 1 says x plus 2y equal to 5. So in this case, we're going to choose the simpler equation. Of course, equation 1 is a simpler equation. So when y is equal to 3, and we substitute it in equation 1, we have x plus 2 into 3, that's value of y, equal to 5. So we have x plus 2 times 3 is 6 is equal to 5, and x is equal to 5 minus 6, and x is equal to minus 1. That's it. Therefore, x is equal to minus 1, and y is equal to 3. Okay, so that's the for solution A. Now solution B is the next. We have B. We have 4x minus y is equal to 17, and we have y is equal to x minus 2. This is equation 1, and this is equation 2. Okay, so for the work is already easy. If you watch equation 2, you find out that y is already the subject of equation 2. So in equation 1, anywhere we see y, we can put x minus 2. Okay, so we'll substitute equation 2 into equation 1 just to make life easy. So we have substitute equation 2 into equation 1. Okay, so equation 2 into equation 1 means anywhere we see y in equation 1, we're going to put x minus 2. So this equation 1, which is 4x minus y is equal to 17, when y is x minus 2. We now have 4x minus brackets. What's the value of y? The value of y in equation 2 is x minus 2. So we now have x minus 2 all equal to 17. So we can have 4x, use minus to open the bracket. Minus times x is minus x. Minus times minus x plus. Then we have 2 equal to 17. 4x minus x is 3x. 3x equal to 17, then plus 2, crossing to this side is minus 2. So we have 3x equal to 17 minus 2 give us 15. And of course, x is equal to 15 divided by 3, which is equal to 5. So our x is equal to 5, and how do we find y? We are going to substitute x equal to 5 in equation 2. Because equation 2 is already y equal to x minus 2. So it will be easy for us to use equation 2 to find the value of what? X. So we now say put x equal to 5 in our equation 2. And that's equation 2, y is equal to x minus 2. When x is equal to 5, y is equal to 5 minus 2, what is equal to 3. When I say therefore, x is equal to 5 and y is equal to 3 becomes the final answer. So the next is question 6. Let's get down to business. Here we have the sixth question, determinants of a matrix. Find the determinant of A if A is equal to this. That's the matrix there, we have solution. Of course, this is symbol for determinant or that A. Okay, whichever way, determinant of A is equal to, we change this square bracket to a straight line bracket. This straight line means determinant. Okay, so we have the line determinant of 2, 4, 5, minus 3, 6, 1, minus 2, 7, 3, then line. So if you observe very well, you find out that this square bracket, I changed the bracket to be a slash, a line. So this line simply means determinant. Okay, so for us to find the determinant of this matrix, we're going to assign a cofactor sign. So the cofactor sign of plus, minus, plus at the top of each column. Okay, so now we have the determinant of A is equal to, you start from 2. Then when you pivot 2 now, the 2 is going to, you rule out this column and rule out this row. Because this row is connected to 2. And this column is also connected to 2. I am starting from this 2. That's how to carry out determinant. So we rule out this row and rule out this column. The only number remaining is 6, 1, 6, 3. So we have 2 into 6, 1, 7, 3. Okay, so we're starting with plus 2. That's the plus 2 here. Then after that, the next number is minus 4. We have minus 4 into, what number will I write inside? I will pivot 4. When we pivot 4 now, we're going to rule out this column and then rule out this row. So when this row that connects with 4 moved out is ruled. with this row column that connects with 4. The number you can see left is minus 3, 1, minus 2, and 3. Then we have plus 5 into, then we'll pivot 5 now. We're going to rule out this column and rule out this row. And the number left is minus 3, 6, minus 2, 7. Okay? So, this is a 3 by 3 matrix. So, it will be difficult for us to calculate the determinant of 3 by 3. That's why we have to what? Present it in this form, such that each of the matrices is now reduced to a 2 by 2 matrix. Had it been we have a 2 by 2 matrix initial, like 2, 3, 7, 1, okay? The determinant of this matrix is simply 2 times 1, which is 2, then minus 3 times 7 is what? 21. Okay? Then when you subtract, you have the answer. So, because of that 3 by 3 matrix, because it's 3 by 3 matrix, we cannot use this method to work on that. So that's why we have to use this particular method in order to convert it to a 2 by 2 equivalent, so that it will now be easy for us to carry out. Okay, so now we have a determinant is equal to 2. 6 times 3 is 18. Then put your minus. 1 times 7 is what? 7. Minus 4 into minus 3 times 3 is minus 9. You put your minus. 1 times minus 2 is minus 2. We have a double minus here. Plus 5 into minus 3 times 7 is minus 21. You put your minus. Then 6 times minus 2 is minus 12. That's double minus there. Okay? So we have the A determinant. We have the A determinant is equal to 2 into, of course, 18 minus 7 will give us 11 into minus 4 into minus 9, negative to negative here, minus to minus is plus, so we have plus 2. Okay, plus 5 into minus 21, and negative to negative is what? Positive 12. Okay, so that the next we're going to have now is equal to 22 minus 4 into, as 2 times 11 is 22, minus 9 plus 4 is minus 7. Plus 5 into minus 21 plus 12 is equal to minus 9. Okay? Is equal to minus 9. So we now have this equal to 22 minus 4 multiplied by minus 7. Of course, minus and minus is plus. So we have plus 28. Okay? Alright, then we have plus 28 plus 5 times minus 9 is minus 45. Okay, so that's equal to 22 plus 28 minus 45. Will definitely give us 5. Therefore, the determinant of A is equal to 5. And that becomes the final answer. Then the next and also the last part of this section note is question number 7. Right, we have number 7 question here. Write each of the following short expressions as simple as possible. We have the first question. A. Of course, it's a way of telling you to simplify the Surdic expression. Alright, we have 2 times the perfect square that is associated with 32, that's two numbers that will multiply itself to give you 32, of which one of the number must be a perfect square is 16. 16 times 2, so you have to be very careful so that the number you're going to use must be a perfect square. Then plus, of course, 18 is 9 multiplied by 2, of which 9 is a perfect square. Minus 3 square root of 4 times 2. Okay? So coming here again, we are going to break up the square roots, break up the square so that we distinguish it. So we have this equal to 2 root 16 multiplied by sub 2 plus here is sub 9 multiplied by sub 2 minus 3 sub 4 multiplied by sub 2. Okay? So when you break them down so that each of the numbers have their own separate square roots. So that each of the numbers have their own separate square root. So we can now go ahead by saying this equal to 2 multiplied by, so the square root of 16 is 4, then multiplied by sub 2. Okay? Plus the square root of 9 is 3, then multiplied by sub 2, minus 3 times the square root of 4 is 2, everything multiplied by sub 2. So we have 2 times 4 is 8, 8 sub 2, plus 3 sub 2, minus 3 times 2 is 6, then 6 sub 2. Don't forget, whenever surds have the same number under the square root, then the surd can be added. Okay? You just simply add the coefficients and also ensure that you attach the surd of 2 at the final answer. So just like when we say the surd are what? Similar. Similar surd contain the same number in their what? Square root. So this is sub 2, and sub 2. It means that these three terms, they are said to be similar. So we have a similar surd condition or situation. So now sub 8 sub 2 plus 3 sub 2 definitely is 11 sub 2. Then 11 sub 2 minus 6 sub 2 is equal to 5 sub 2. Therefore, the answer is equal to 5 sub 2, and that eventually becomes the final answer. Then the B part of it. The B part of it, we have 22 over 4 minus sub 5, and that's of course B. And in this case, you see the denominator is a binomial surd. Binomial surd means a surd that has two terms. This is the first term, this is the second term that contains surd. So this is the binomial surd. So we're going to use rationalization. And if you want to rationalize, that's rationalization by conjugate. The conjugate of this denominator is changing this minus to what? Plus. Okay? So the conjugate of 4 minus sub 5 is 4 plus sub 5. So we're going to multiply both the numerator. This is 22 over 4 minus sub 5. We're going to multiply everything at the top with 4 plus sub 5. That is the conjugate of 4 minus sub 5. Divide by the same thing, 4 plus sub 5. So we're going to multiply both the numerator and denominator by the conjugate of this denominator. So conjugate of 4 minus sub 5 is 4 plus sub 5. We're going to use it to multiply both up and down. Okay? So we have 22 multiplied by 4 plus sub 5. Okay? All over that's 22 multiplied by this guy. All over this difference of two squares. Of course, here is negative and here is positive. So to every difference of two squares, we're going to have 4 squared. Once this difference between this term and this term is in their sign, the first is plus and the first is minus and the second is plus. What you just simply need to do, since you've already observed that the only difference between this and this is one is negative and the other one is positive, it simply means difference of two squares. The square of the first number minus the square of the second number. Let's subtract all square. And of course, that is equal to, we are going to carry out the multiplication. 22 times 4 will give us 88. We have 88 plus 22 multiplied by sub 5 is 22 sub 5. Okay? All over 4 square is 16 minus, of course, sub 5 square is 2 to cancel the surd. We now have 16 minus what? 5. So that this is equal to 88 minus 22 sub 5 all over, of course, 16 minus 5 is equal to 11. Then when you divide further, you're going to have this to be equal to, of course, 88 divided by 11 and 22 divided by 11. Of course, we're going to have 88 over 11 minus 22 sub 5 over what? 11. Because both numbers, they are having the same denominator. So same denominator, you're going to separate it this side and this side, such that we have finally 88 divided by 11 is 8, minus 22 divided by 11 is 2. So 8 minus 2 sub 5 eventually becomes the final answer. Thank you and God bless you. I remain my humble self, Mentor the Great. Please subscribe for more. Have a wonderful day.